First of all, I'm not presenting all results from my whole dissertation. For a practical reason, not all of them are already ready to show. But I present a part of it. What I've been doing is I was interested in the effects of software patents on what FOSS developers are doing. So there can be two aspects to look at. One is motivational, and that's what I'm going to talk about today. And the other one is effects on innovation. Just to start with a small question to you. What's your opinion about this statement? The statement says, I think the availability of software patents does affect the motivation of a FOSS developer. So you can say yes, no, or you cancel. Let's assume you say yes or no. So who would say yes? Okay, who would say no? Okay, who cancels? There's the exit. All right, so most of you think, okay, there is probably an effect. So as you've been saying yes, there's of course a follow-up question. Would you rather think the effect is positive or it is negative? So I don't have a slide for that. So who thinks the effect is rather positive? Please raise your hand. One and a half, okay. Who thinks the effects are probably rather negative? Okay, quite some more. Well, looking at, well, so we can take two positions, and one is the position of the proponent saying, yeah, there should be positive effects, and one is there of the opponents. So software patent proponents, for example, might say, well, software patents work just like all other patents work as well in other areas. You can think of patents in medicine, in biotech, in pharmaceutical industry, in civil engineering in general, of course. Okay, and they're saying, well, open source might be a bit different than other types of software, or software in general is a bit different, but it's not so different that patents should not be applicable. So we think, yeah, it should work, and of course we expect positive effects, like in other areas we can see them positive as well. The opponents on the other side have one of their positions is, well, patenting of software, we think it does not work because of the way software in generally behaves, and then how open source is developed and how its mechanisms are different from proprietary software. We think it just doesn't work. In addition to that, we also think they are simply not needed because the software industry, proprietary or open source, has been thriving over the last decades without a lot of patents. But on the other side, we think, well, if they are there, they can do harm. We are not exactly sure how this could happen, but we think patents in software are rather harmful. So they expect negative effects on motivation. Now, on that level, it sounds, if I ask people, well, most of the FOSS developer people I ask would say, yeah, they're negative, and people are quite quick in having an opinion, yeah, on saying, yeah, first of all, there is an effect, and then it must be negative or it must be positive. But what are we actually talking about? Motivation is such a broad term. So when I've been asking you what you think about the effects on motivation, all of you probably thought of different things when thinking about, well, motivation, yeah, of course. But what types of motivation are there? Developers can be motivated by many different things, and researchers, at least the ones I read from my dissertation, found 16 different types of factors, or different types of motivation. And I want to quickly show you these 16, so you get an overview how broad and actually also diverse this motivational setup of a FOSS developer can be, theoretically. Does it, can I, oh, okay. Rather small. So the first 8 are structured in instant or delayed rewards. And we're talking about so-called extrinsic motivations. Meaning, extrinsic motivations, you're doing something to get something else, which is external to you. So, for example, you work to get money, and you get money to buy things. So, and if you look at these, so learning of new skills is one of the potential motivations. Helping yourself by developing your own solution. So you have a program and something is missing and you desperately need that functionality, and it's open source, so you can just help yourself. Well, that sounds quite academic language. Low sharing costs compared to return of code shared by others, meaning you usually get much more code back than what you actually program and contribute. You contribute, let's say, a few hundred, a few thousand lines, and you get back a few several millions. And, of course, there are people, some of them are wearing red hats, they're getting paid for programming open source software, so they have a direct monetary reward. Delayed incentives, meaning you are not getting it instantly, but later, is you contribute, you expect others to contribute as well. So when you contribute today, you expect in the future others will also contribute to the program, and it will be improving. Even if you perhaps stop contributing or contribute less in the future. Peer recognition, reputation. Somebody who can say, well, I worked at Mozilla, for example, in the Firefox project, the last 3 years, I did this and that, I can show you. That's a way to gain reputation, which is one of the important assets in the open source communities, because money obviously isn't the factor showing success or failure of people. Related to that is the third point, is future career. I mean, you just write down your experience with Firefox, Thunderbird, and perhaps the Linux kernel on your CV when you apply for a job somewhere, and it says something about your capabilities as a programmer. And then there is also let's say, political aspects. Some people in the community have a stronger stand on that software should be free, or fighting against the monopoly. We've heard today already other presentations using other means of fighting the monopoly. All right, so that's the first half of these motivations, and you can see they're quite diverse, and yeah. And you can think, for the ones of you who are actually developing open source, where would you say, oh yeah, that's true for me, or no, I haven't thought about this at all, etc. All right. The second half of possible motivation factors is intrinsic, meaning they are inside the person. So one famous example is fun. People just like programming, like writing code, like other people like playing an instrument. Self-expression, coding as an art. Some programmers say, I really like to write beautiful code that just does not only fulfill a certain purpose and solving a problem, but it does it in a very elegant way. Very short, very, I don't know, aesthetic, self-expression. So, and as you have different possibilities in writing a certain piece of source code, you can choose more elegant or less elegant ways. Altruism, meaning helping others, is something which is prevalent in the open source community as well. Code sharing has some intrinsic altruistic aspects. This possibility of solving problems on your own can also have this aspect of ego boosting, let's call it. People like solving challenging programming problems. You are the first one who got DVDs running on a Linux machine. I'm not talking about the legal aspects, just talking about the technical, the code needed to make it happen. So all these factors I've been talking up to now are enjoyment-based, I call them, because they are somehow related to something people like. On the other side, on the right side, you can see aspects which I call obligation-based, meaning they are also intrinsic, but there is a certain notion of, I feel I should do it, to it. So first, identification and sense of community. I think you all understand what I want to say, express with this. Along with that goes observance of community norms. I mean, certain open source is also a culture. Certain things are expected that people are doing when they are part of this community, and some things are expected that they're not doing. So sharing something you would expect, keeping stuff for yourself, or I don't know, trying to sell everything you produce is perhaps something people would not expect. Then, again, a political mission that software must be free. This is not the same as fighting against proprietary software from the previous slide. Because these people who formulate these statements say, I mean, I don't care what other companies or organizations are around. I just think software should be free, and I'm dedicating my time and energy to do that. And the last one, I'm not so sure if it ever occurred to you how your friends and relatives might actually look at your engagement in open source. So, but it's not completely, I think, esoteric, because, for example, people could be members, active members in Greenpeace or in other organizations, and that also says something about them, and people around them, relatives, friends, then have a certain opinion, and you might rate this opinion high or not so, and depending on that, it can have an effect on your motivation. So, all right, that's a lot of motivation, hopefully. I mean, that's created all these millions lines of code, after all. But now the question is, which of these factors are actually affected by software patents being present somewhere in a jurisdiction? And how are these effects? And probably most of you until now have been thinking, oh yeah, patents are the bad thing. I mean, that's what usually the open source community is talking about. So you have to defend against something, a threat from outside. But could it be that developers actually hold patents on their own for one reason or the other? And then that has also implications how they view patents and on their motivation. And if you want to answer these questions systematically, you will have to take these 16 motivation factors I showed you and create a huge, nice table, which is 4 times 16, with 64 cells, the motivations and the effects, positive or negative, and whether it's an external patent threat or it's you have a patent on your own. Anyway, you analyze these cells, that can be your homework, and find arguments for each cell, actually. So I did that somewhere in the past, and out of that exercise I selected 5 motivation factors, and out of these 5 I formulated 5 expectations. And because it should be objective, I mean it's an academic exercise as well, I took 2 statements representing proponents of software patents, and I selected 2 statements which could be representing opponents, and 1 which I couldn't decide where to go, so it's for the undecided people. All right, so these are the 5 expectations I formulated prior to getting my data. I said, all right, so proponents generally support the idea of patenting software, and they expect positive results. So first expectation, software patents affect money, earning money, as a motivation positively. Second expectation of proponents, software patents affect skills, which means learning new skills. Perhaps you remember on one of these, in the first table there was this learning new skills as a motivation, as well positively. And here the argument is that a patent is supposed to disclose the invention, meaning in the patent letter you should be able to read what the invention is about and how the invention works. So you can actually learn something when you read patents, or you should. So opponents have also two expectations. One is, and of course they are negative, as we saw earlier. So software patents affect joy, having fun doing programming, negatively, because with all this legal hassle, it just reduces the fun of doing it. And the other expectation would be software patents affect self-expression negatively. And with self-expression, I mean this ability to write elegant code, because and the argument is because when there are software patents present or available in a certain area, your freedom in formulating the source code the way you want is restricted. So the consequences the effect should be negative. And the fifth expectation, I wasn't sure where to put it, and it's also not directly proponents or opponents. It says software patents affect the motivation. The last one I was bringing up, that software should be free, but I'm not sure which direction. It should affect it somehow, but there are arguments that it's negative and there are arguments that it's positive. All right, to find answers to these 5 expectations, I asked many developers. I contacted many more developers, project leaders of SourceForge, and asked them a few questions about experience of software patents in their projects. And I'm very happy that 2,441 responded to me, so I could use this data to try answering these questions. And whenever you have the task of asking many thousand people something online, I recommend using this nice survey tool, which is called Lime Survey. And yeah, so. Okay, some results. First, I want to show a few results not yet related to these expectations, but just because it's also just interesting data to see. And then I'm showing some of the results about these expectations I formulated. So of course I was asking these people about these 16 motivations. And if you rank them, that's what you get. You see that, for example, joy is on the top. So most of the people said joy is very important for them. And interestingly, on the very other end, you see earning money. Yeah, of these 2,440 people, most of them put earning money at a very low level, and therefore it's ranked at the last position. I marked with colors the motivations connected to these 5 expectations I was telling you earlier, showing you earlier. And yeah, it doesn't show a lot, but with with a lot of goodwill, you could say that the reddish, the red motivations are like a bit more up in the whole ranking than the green ones. The green represents the last one, red represents the first one, okay? And the blue one, this undecided, is obviously not so important. I also asked people, all right, because that's actually information we are missing. Software patents have the characteristic of being tied to jurisdiction. Yeah, in a certain country, jurisdiction, legal system, you can patent software or you can't, and there's unfortunately actually there's a gray area between 0 and 1, everything in between, because it's just. I spent 3 months in Munich at the Max Planck Institute for Intellectual Property. A lot of patent lawyers and other people dealing with this stuff, and nobody could help me in just making a list with the countries and saying something about the patent situation, software patent situation, in a more or less easy way. All right, so this country aspect, jurisdiction aspect is one. And the other one is, you all know we have different fields of programming, different domains of software. You have multimedia software, you have office software, you have cryptography, you have, I don't know, internet stuff, whatever. So I took for the ones of you who are familiar with SourceForge, they are structuring the projects which are on the website, and the top level categories are these 14, which you can see here. I condensed it a bit, so there are 2 or 3 in the other category, but they're obviously also not important. And I asked people, okay, this is the list of these areas, again, ranging from office software to internet software to cryptography software. Please pick the 4 areas you think are mostly, where most software patents are around and present, where areas where there's just a lot of these software patent problematic showing. And they just made 4 crosses, and that's the result. So what you can see is, without looking at what it says at the top, at the bottom line, you see top 2, I'd say, because there's quite a gap, and you see bottom 2 and a quite large middle section. Okay, the top 2 are multimedia. Okay, think of MP3 and other codecs, for example. And everybody probably nods, oh yeah. And the other interesting thing is, and I can again link to the presentation from the Commission this morning, this stands for frameworks and protocols, meaning patents on frameworks and protocols, not on actual applications. And people rated this second highest in terms of, okay, that's an area where there are a lot of patents around, and it's, yeah, critical. And then, of course, education and editors, nice category, editors, doesn't seem to be very relevant for software patents. And in the in between, you have all these different areas. So office and business software, communication, security, encryption, etc., software development, tools, scientific engineering, internet stuff, system software, desktop, databases, and games. So games is the last one here, and office comes with quite a gap at the 3rd position. All right. So that's the first time we actually have such a measure. Until now, we only have this anecdotal evidence that, oh yeah, I've heard about this problem with a patent here, and the current case is TomTom. But we haven't had an overview like this where actually the wisdom of the crowds was tapped to find out how the situation on a more aggregated level looks like. And the next result, before I come to the expectations, is this small number, 1.6%. That's the number of actual software patent incidents, Zwischenfälle. These 2,441 people reported, meaning actual incidents with software patents are a very rare event. It happens rarely. You have to ask a lot of people to get a few of them making a tick, oh yeah, we had a problem and that was the problem. It doesn't mean it has no effect, it's just a rare event. It doesn't happen with every 3rd project. Okay, now coming to the expectations. Again, the proponents first. The 2 expectations that I postulated on top, and the result is that both of them are not confirmed by the data. Meaning, I couldn't find a correlation between software patents being available and these 2 motivation types. So that means no visible, at least with this data set, no visible positive effects. I mean, that alone is also is a result in the sense that people arguing in favor of patents also in the software area do not get support by this data set for their position. It doesn't say it's the opposite case, but they don't get support. So some of you might say, oh, I'm sorry to see this slide, because the opponents also do not get support in their 2 statements. Because also both are not confirmed by the data. And I have an interesting thing here. Perhaps somebody has an idea and to give me why this could be the case. So there was a correlation between software patents being available and joy as a motivation, and actually it was positive. So, yeah, I haven't fully figured out how this could be explained, but perhaps you have an idea. But in any case, the result for the position of the opponents is there are no visible, measurable negative effects. This does not deny the fact that we have this anecdotal evidence, and we can cite a few examples where patents played a negative role. But on a larger scale study, a bit more systematic, we haven't found negative effects. And the last one, hooray, there we saw, or we found something. So software patents affect the motivation of software should be free. And now it's also clear that it's not somehow, but it's it's a negative effect, meaning the presence, the availability of software patents has a negative effect on these people who say, oh yeah, free software is very important, freeing software is very important for me. Which, yeah, is not unintuitive, I'd say. I have one more result to show you, which is not directly linked to the software patent question, but I think it's still interesting, and it's about income. The question is, what role does money play in all this? If people have income or not, and if they get it from open source or not. So, probably most of you would agree with me that income plays a role in any type of motivation. The ones of you who earn money for doing whatever you do plays a role for why you do it. The interesting result here is that getting income from FOSS programming and developing, and here I really mean only getting income from either developing open source software or working at a place where open source generates the income. You don't have to be the programmer there. Perhaps you develop, you participate in a project in your spare time, and through the day you work in a company who also makes money with open source software, but there you're not programming, you're doing something else. I found results, or I can show you 3 effects that earning money from FOSS has a positive effect on the people who are motivated by money, which is okay, a no-brainer. But the other 2 are interesting. Actually, it can have a reducing effect on the people who are strongly motivated by joy, saying, okay, it's fun for me to program. And the ones who say, yeah, software should be free, and that's the reason why I'm doing it. For both of them, income can have a negative effect. Researchers call this crowding out effect. In a more general statement, it says, when people are intrinsically motivated, and these are 2 examples, yeah? You have fun doing it, or software should be free. When people are intrinsically motivated doing something, and then you start offering external incentives, like for example, you pay them money, this may reduce or even destroy the original intrinsic motivation, which is quite interesting. So, okay, it's actually 2 sentences, my conclusion, and again, it's just a small part which I can show you, and I hope it was not too heavy on the academic language side. First, software patent availability and also incidence, actual incidents, obviously do not play a significant role for motivation in general in these 5 aspects I showed you, except when people are motivated by this freeing software. In other words, neither the proponents' positions and arguments actually, nor the opponents' positions and arguments are supported, at least through the results of this study. And the second one is what I just showed at the last slide, previous slide, that the effect of FOSS income is not universally positive. So we should not expect that all FOSS developers just get much more motivated when we start paying all of them. It depends on the motivation type. So where from here? FOSS is about motivation. We all know that. It's volunteer, many volunteers participating in a community effort. That's the one side, and the other side is these patents are about innovation. They are instruments designed to foster innovation. That's what they are here for. That's the task they have to fulfill. And my next question, which I am currently working on, is: do software patents affect innovation in the area of open source software? So I'm going one step further, leaving the motivational aspects and looking at actual innovation. And I can tell you, it doesn't get easier in answering these questions. One of them, which I'm doing as homework right now, is what is FOSS innovation actually anyway? If I ask the what would you ask FOSS developers to at the end be able to say, oh yeah, more or less innovative than the other guy? Thanks.
Thank you, Marcus. It's very interesting to see that there's no effect, which is also sometimes quite the insight. Are there any questions from the audience concerning this scientific study on patents? So will this be another paper for the FOSS innovation?
Yeah. That's exactly, yeah. I just finished the paper writing about this motivational aspect, so if you are interested in the details, I mean, this was really very, as I said, lightweight presentation of the results, but there's possibilities to read the paper online and get more meat to the bone, actually. And the next paper will be on this innovation. I have an idea, which I also used, of course, in the survey. Perhaps I'm asking you a question. I asked the developers in the survey. Okay, first of all, my idea about measuring this innovation is, I say, there are different ways of writing code, or different types of writing code. So for example, you take mainly existing libraries, put them together, just the necessary glue to get it work, and you produce something which produces something useful piece of software. It's sort of new because you combine stuff which hasn't been combined yet, but it's not, I mean, you didn't think a lot of new algorithms or whatever. Then there is this middle middle area, where you also perhaps combine stuff and you add more of your own thinking. This can be functionality which is existing and you just implement it again, or you actually think of new things. And so I build a scale of 6 levels. Reverse engineering is also an aspect, but I wouldn't put it here in the innovation categories. So people could make crosses if they primarily work on implementing new algorithms from books or from somewhere they thought about, or if they're actually doing work which is perhaps less intellectually challenging in the sense of combining different existing modules and components.